Hey again, it's Mr. Lum, and today we're going to be continuing on learning how to name ionic compounds, but we're going to be doing polyatomic ions and how are they named. So you should have a polyatomic ion sheet or like a periodic table. If not, you can go into the Microsoft Teams and find it on the attachments there, and you can find like the data booklet there. And if you do have a physical copy, I have the periodic table on one side and all your polyatomic ions, common polyatomic ions on the back side. Anyways, on that back side, you should have, you should see something that kind of looks like this. It has the positive polyatomic ions, and we just have one right here, which is ammonium. We have negative ions, and this list continues further and further down. So what a polyatomic ion is, it's an ion that is made up of more than one atom. So the word poly means many, as in many atoms, and atomic, well, that just means atoms. So polyatomic just means many atom ions. So here's a couple of examples. So here's carbonate, which has one carbon and three oxygens. So that's why it has many atoms, and it is an ion. It has a -2 charge. So on the periodic table, like oxygen has a 2- charge, carbonate also has a 2- charge. Okay, this subscript number and this subscript number and all these subscript numbers, subscript means the number that is below, has nothing to do with the charge that is above. So this has a subscript of 4. That means there's 4 oxygens here, but the ion itself has a 2- charge. Okay, so just keep that in mind, and we'll take a few examples in a second. So how do we name things that are polyatomic? So I have a couple of steps right here. Naming ionic compounds that contain polyatomic ions. Identify the ions in the formula is the first step. Name the positive first, and then name the negative second. So here's our first example. Now the hardest thing to do with all this is figure out which one is the polyatomic ion, which one's the positive ion, which one's the negative ion. So we're only going to be dealing with one type of positive polyatomic ion, which is NH4. So essentially, if it's not NH4 at the beginning, so this one we have NH4 at the beginning. If it's not NH4 at the beginning, then how you divide the positive from the negative is you just say, okay, where's the first element? Right there. And that means this is the positive, and this is the negative. Okay, so for this one right here, here's the first element right there. So that means this one's the positive, and this one's the negative. NH4, that is one of our positive ions. So again, this one right here, that is the positive, and this side is the negative. Okay, so that's the hardest part about doing these kinds of questions right here, is figuring out which side is the positive and which one is the negative. So now that we've done that for all of these ones, we're going to name the positive ion first. So here's NaClO3. So we have the positive ion first. We're found it right here. So I have a little piece of the periodic table for us cut out, and it says that it's sodium. So I'm just going to write sodium. And then I have ClO3. Now, I know this is going to be a polyatomic ion because it contains more than one atom. So I just go to this polyatomic ion sheet, find where ClO3 is. Here it is right here. And I write it down exactly as I see it. I don't change the suffix, I don't change the ending of the word, I don't change anything about it, just keep it as is. So it says chlorate right there, so I'm going to write chlorate. So sodium chlorate. And that's done. Okay. So it's a little bit easier than some of our other ones. So again, here we have the positive ion for this one. We found it right here on this little piece of the periodic table. So it says it's magnesium. And then we find where CO3 is on our thing. Here it is right here. I just write down this word right here, which is carbonate. Okay, here, a little bit different. There it is right there. It's our only positive polyatomic ion. So I'm going to write ammonium. And then we have Cr2O7. So we find that one way down there. And it says it's called dichromate. So I'm going to write dichromate right here. I want to emphasize that even though this is the only positive polyatomic ion that we have right here of NH4+, it doesn't mean that that's the only one in existence. That's the only one that we're going to be using for our course, is ammonium. But there are other ones out there. Okay. So now, how do we go the other way? Okay, so now what we're given is, we have another couple of questions right here, and it says Cu2SO4. So same thing, I have to find where the division is. So here it is right here. It's not NH4, so it's just going to be the first element. So here's going to be my positive ion, and here is going to be my negative ion. Now I see that I find where Cu is on the periodic table, and I've cut out the piece of the periodic table so that we can easily see it, and we see that it's copper. Okay. Now, one thing that I'm noticing right away is that copper is multivalent. So that means it must have a Roman numeral involved. So I kind of have to do a little extra step right here. So I'm going to show you, we have to use from our last lesson. We're going to do the old reverse swap and drop. So I'm going to write Cu 2+ and 1+, and then I'm going to write SO4, because SO4 is part of this one right here. That 4 is actually part of sulphate, and then it has a 2- right there. Okay, so again, this number right here is we're going to reverse swap and drop, and it went from a 2 to a 2. Now for this one, a lot of people are going to think that this is a 4, but it's technically, there is only one SO4 here. That 4 is part of this whole polyatomic ion thing. So there's a 1 right here. It's not a 4, it's a 1. I know it's a little bit tricky and a lot of people get confused about it. But when we swap and drop, it comes back up right here. And then we circled the one that we used. So the one that we used, which copper we used copper 1. So when we write the name of this, we have to write copper 1, because we use the 1 ion, and I circled it over there. So we use copper 1, and then SO4 sulphate. Okay, and then some people like to put brackets around these things. So copper 1 sulphate. So next one right here, we don't have NH4, so it's just going to be the first element is going to be the positive, and this is going to be the negative. Now, we look up where silver is. Silver is not multivalent, so it does not get one of those numbers. Now, so we write down silver, and then we write down SO3, which happens to be called sulphite. And then we're done. Now the reason why I picked this question right here is because there's a huge difference between sulphate and sulphite. Okay, and then and the difference is that whole oxygen right there. Okay, so they are completely different compounds that will react in very, very different manners. So that's why we make sure never to change the suffixes of our polyatomics. Now, the next one is, how do we go the other way? We're given the name of this thing, and we have to come up with the formula. So I have 3 steps right here. We have sodium sulphite is our first one right here. So first we're going to identify the ion charges. Okay, and so I'm going to write sodium, and here it is right here on our periodic table. So it's going to be sodium, it's going to be Na plus. And determine the ion charge. I kind of should have said something a little bit better, like determine the ion charge or write down the ion charge of the negative ion. But we have sulfite. We looked at it on the polyatomic sheet, and it says SO3 2- right here. SO3 2-. Now we're going to write this below, and we're just going to do the old swap and drop. So we're going to take just the ion and we swap and drop the ion. We only swap and drop things that are up there. So remember, even though this is a plus, there's a 1 right there, and this 2 gets swapped and dropped, so it becomes Na2SO3, and there would be a 1 right there, but we don't bother writing ones, so it just says Na2SO3. Okay. Now I'm going to take a little bit harder one, iron 3 phosphate. So again, I like going this one because it tells us which ion it uses. It uses the iron 3 ion. So I'm just going to write that already out, make a little divider right here. So I'm going to write iron 3 ion. And we have phosphate, PO4 3-. Okay, now we could use the swap and drop, but I'm going to use that other method because what I'm noticing is that, hey, this is 3+, this is 3-, the total charge is 0. So that means we don't need any subscript, so it can just stay as FePO4. Just like that. Now I'm going to take this one right here, ammonium phosphate. So we have ammonium, that's our positive polyatomic ion, so I'm going to write that one out. NH4 plus up there, and then I'm going to write phosphate, which is PO4 3-. Now I'm going to write it down below. And I'm going to swap and drop. So we only swap and drop the ions. And now this is a 1 right here. So I'm going to pull that one over here. So what it would look like is something like this. It would look like NH4 and this 3 right here swapped and dropped down. So we put a 3 right there. Then you write PO4. And then we write the 1 right there. Now it kind of looks like NH43PO41. Okay, so first off, we don't bother writing the 1s. Okay, now it still looks like it says NH43. Now that's where this step number 3 comes in handy. Use brackets around a polyatomic ion if there's a subscript number that we've added. So there is a subscript number we added. We added this 3 subscript number that swapped and dropped down to here. And so what we need to do is we add brackets around just the polyatomic ion. So I'm going to put brackets around this, like that. So it says NH4 bracket 3 PO4, or maybe if I write a little bit nicer looking, NH4 bracket 3 PO4, and that would be our answer. Okay. So here's a couple, 3 little questions right here. You can put the video on pause, see if you can come up with the answers very quickly, and then I'm going to also write out the answers. So put the video on pause right now, and then and hopefully you get the same answers as me. Anyways, The first one right here, we have sodium sulphate. I find where sodium is, right there. So I'm going to write that. Na plus sulphate. Way down there, it says SO4 2 minus. I swap and drop Na to SO4. That's because that swapped and dropped. And that's my answer for that first one. Second one, manganese. Here's manganese right here. We're using the 2 because it says so. Manganese 2 plus. And then we're going to have combined with hydroxide, which is right there, which is OH minus. Swap and drop, MnOH. Now, we have that OH right there, so it deserves to have the bracket, so it should say Mn bracket OH bracket 2. Okay, and that's the answer right there. Now going the other way, we have Mn2SO43. So I'm going to write that down here, Mn2SO43. We have some brackets there. I'm going to write Mn and then SO4 2 minus, because SO4 2 minus, that's the charge of SO4, is 2 minus. Now, so right here, I'm going to do the reverse swap and drop. That went from a 2 to a 2. Now, manganese can have a 2 plus, a 3 plus, or a 4 plus ion. So when we reverse swap and drop, we have to go from this 3. So which one? Was it a 2 plus, 3 plus, or 4 plus? This went from a 2 to a 2. That means this one went from a 3 also to a 3. So this is 3 plus. And so therefore it's going to be called manganese. Since we use the 3 ion, we have to call it manganese 3. And then SO4 is called sulphate. I'm running out of room here. Sulphate. Okay, and that is hopefully the answers that you came up with as well. Box that in so you can see it clearer.